you are so inclined. If you're not so inclined, so be it. Okay, so anytime you're trying to write a linear inequality, or an equation for that matter, you need to try to find a way to organize your information. Okay, there's going to be a lot of information in these little tiny paragraphs, and some of them are not little tiny paragraphs. Okay, Nathan, they're a big, long, extraneous, more than a tweet paragraphs. A lot more than 144 characters. Okay, but still you have to identify your variables and your constraints. Okay, and we'll talk about what the constraints are when we get to these two problems, number 1 and number 3. Identify your variables and your constraints. Okay, and then the last thing you want to do is you're going to write linear functions and inequalities from your variables and your constraints. Okay, so the hardest part is determining how you're going to organize your information. Okay, what kind of things go together, what kind of things don't go together. Okay, so let's do problem number 1. Good old Sally and George, they have a car and a truck. Okay, so if one day you are in a happy relationship, you might have 2 vehicles to drive around. Okay, with some constraints. The car gets 34 miles per gallon. That's the maximum miles per gallon it can get. Okay, and it has a 16-gallon gas tank. Okay, that is a constraint. You can't put 20 gallons of gas into a 16-gallon tank. It's going to waste 4 gallons of gas and spill it all over the floor. You don't want to do that. This is a constraint. Okay, the truck has some other ones, 18 miles per gallon, and it has a 24-gallon gas tank. Okay, it gets less MPGs, but it holds more gas. And here is another thing. They can only afford to split 40 gallons of gas a week. Okay, they budgeted, with the way the economy is nowadays and the price of gas, okay, they can afford to spend $40 or 40 gallons of gas per week. Okay, so here we have our thing. There's your whole setup. 2 cars, you have some things about the cars that you know, and you want to write 3 equations that relate the amount of gas to the vehicles. Okay, your problem is not going to tell you that. It's going to ask you to solve something right away. This part is bonus extra that I threw in because we're just writing inequalities today. Tomorrow, they will not tell you to do this, but you're going to have to do it anyway. Okay, so 3 equations that relate the amount of gas to the vehicles. Okay, so let's put in some vehicles we have. You got yourself a car, and you got yourself a truck. Do you want to use obvious variables or less obvious variables? Obvious, we'll call car C, C for car, and K for truck. Only because my T's and pluses look a lot the same. I don't want to confuse anybody with pluses and T's. Okay, so let's see. What do we know about our car? We know that it has some miles per gallon and that it has a gas tank, right? Some size of gas tank. So this looks like a very nice chart where you have 2 things on the left, 2 rows, followed by 2 columns. So maybe a nice little matrix looking thing, but we're not going to make it into a matrix, don't worry. So how much miles per gallon does a car get? 34 miles per gallon, and it has a tank size of 16 gallons. Okay, your truck gets 18 miles per gallon, and it has a tank size of 40. 24? Me caramba. Seriously, what is today? Monday? Friday? I don't even know. Someday. Today is Sunday. 24 gallon tank. And let's see, what else haven't we said yet? We haven't used 40 gallons anywhere. Okay, so let's write our 3 equations. What about your car? What is the maximum amount of gas that the car can hold? 16 gallons. So the car can hold less than or equal to 16 gallons. Okay, that is a straight up constraint. You cannot put more than 16 gallons of gas into your car. That is one inequality that is only related to the car. Okay, give me another inequality related to just the truck. 24. Okay, you cannot put more than 24 gallons of gas into your truck. So C is less than 16, K is less than or equal to 24. Now how do they relate together? What's the third relationship between the gallons? What's that? Right, so if I add these two things together, C plus K has to be less than or equal to 40. So we have a car gas relationship, we have a truck gas relationship, and then you have one between the two of them, because you can only afford 40 gallons per week. And so those are your three inequalities. Now what about these miles per gallon things here? Why do we even why is that even a part of this question? Well, that's here what we want to maximize. Okay, your maximizing equation. Out of our 40 gallons of gas, we want to be able to drive the farthest that we can. Okay, so your maximizing equation of miles, I guess we're going to talk about miles, how many miles you can drive. We want to drive the most amount of miles on these limited amount of things. The miles that you can drive is equal to 36 miles for every car gallon plus 18 miles for every truck gallon. Okay, so all of these things, here's your maximizing equation, and these are your other constraint and relationship equations. Okay, so like I said, you might want to relate a miles per gallon thing. These are going to be adding up. You're going to want to add them up to something, right? You're thinking linear equations, they have to add up to something. Well, they do add up, but that's what you want to maximize. You want the most miles for every gallon. So we take 36 times however many gallons you put in your car, plus 18 times however many gallons you put in your truck. And that will give you the farthest you can drive. So what we're going to end up doing is graphing these things. Okay, we're going to graph them on a grid, and we're going to see where each of these lines intersect. Just like we were doing on Friday. So if this is our grid, we're going to graph these things, and we're going to see where they cross. So we'll have points, your vertices of in this case, a pentagon, where all of these possible answers are potential. We can put 1 gallon in 1 gallon, we can put 16 gallons in 5 gallons, whatever. So what we're going to do tomorrow is we're going to end up graphing each of these things so we can see where they cross. Okay, you get the points of your vertices of your polygon in there. So that's where this is going. But you have to be able to write these equations first, and the equations are the hard part. Okay? So this is one with constraints where it's strictly less than. You can have not more than 16 gallons here, not more than 24 gallons there. Okay, number 2 on your worksheet is a lot like this one, number 1, which is also BT dub on your worksheet. Hence the number 1. Okay, I'm not trying to kill you with a bunch of these equations. You can do with 3 practice ones and be just fine. So, I mean, the assignment was like 14 of these, but we'll do 14 just in chunks of 2 and 3 because they do take a while. I will let you know. Okay, so there's number 1. These are your constraint equations, a relationship, and then a maximizing one. Okay, so let's take a look at number 2 here. Okay, like I said, really wordy. Life does not give you any equations. They're all word problems. Let's see. Desks and bookcases. So those are your 2 variables. Let's write those down. That would be good. We're making desks and we're making bookcases. Indeed it is. On the paper here, well, your paper is number 3, but this is number 2 example. I know, very confuzzling, sorry. Lo siento, te gusta. So, bookcases and desks. Those are the two things that you're making. Okay, each bookcase requires 5 hours of woodworking and 4 hours of finishing. Okay, so we have two constraints on our bookcases. We have woodworking. That's like actually cutting out everything and putting it together, I'm assuming. Maybe just cutting out everything. And finishing, which might be gluing it together and staining it and sanding it and making it all beautiful or whatever they happen to do. So each, let's see, each bookcase requires 5 hours of woodworking and 4 hours of finishing. Each desk requires 10 hours of woodworking and 3 hours of finishing. Okay? So each month the shop has 600 hours to allocate for woodworking and 240 hours for finishing. So it looks like we have maximums here. Maximums. For woodworking is how much? 600 hours for woodworking, and finishing is 240 hours. Then the profit on each bookcase. So here's another one over here, profit. Let's do profit in purple. The amount of money that you actually make, $130 for each bookcase and $85 for each desk. Write a system of inequalities that relates woodworking and finishing for each product, and then a profit function. Okay, so we really need to make sure that when you do these, you keep the units the same. Okay, write down things that are in like units. So 10 hours, looks like these are all in hours, 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 hours. So all of these are in hours. This is cash and this is cash. Money here, money there. So 85 should not go with the hours because it's not the same units. So usually if you organize it in this manner, your equations come from the vertical columns. Okay? All of these three things are all talking about hours of woodworking. So we're going to have a woodworking equation. Okay? These three are all talking about finishing. So we're going to have a finishing equation. And then, of course, you're going to have a profit function, how much money you make off of these things. Now, of course, there's no dollar amount here because this is what you want to maximize. You want to make the most profit possible. So that's not going to have a constraint. Hopefully it's larger than 0 if you want to make money. So we're going to have a woodworking inequality. Okay? So woodworking, we have 10 hours for every desk, so 10D, plus 5 hours for each bookcase. If we add those together, we cannot exceed 600 hours. So that's what makes it an inequality. It can be less than 600, that's fine, but you cannot spend more than 600 hours for woodworking. Okay, so here is your linear inequality. 10 hours for every desk plus 5 hours for every bookcase is less than 600 hours. These are all about woodworking. Okay, and then we have our finishing equation, okay, which also has two variables in it. 3 hours for every desk plus 4 hours for every bookcase cannot exceed 240 total hours. Okay, so it's a two-variable system, okay, desks and bookcases, but they each have two different constraints placed on them. Okay, which is why you get two equations. One constraint comes from your woodworking, or rather one equation comes from their first constraint. The second equation comes from your second constraint. Woodworking and finishing. So what's going to happen, like this could be your x variable, and this could be your y variable. So we put them on a nice grid, and we'll graph them. Bookcases versus desks. One will be dependent, one will be independent. It really doesn't matter which one you do. The answer is the same either way. Okay, so you'll solve one of these for maybe B, and then you'll graph it, and we'll solve this one for B, and we'll graph it, and they'll cross somewhere. And that point that they cross will be how many of each you should make in order to maximize your profit. And then you multiply it into your profit function. Oh, let's do our profit function. Profit is $85 for every desk plus $130 for every bookcase. Okay, so once you graph these things, you're going to figure out how many desks and bookcases you're going to be making, and then you multiply them into your profit function. Okay? So this is actually how some businesses determine how many of each thing they can make and how many people they have to hire based on productivity and how many things they need to produce in order for them to make money. Okay, so like I said, this is number 3 on your paper. You will do number 2, which is like number 1, and then numbers 4 and 5, which are similar to this one here. Okay, I believe number 5 is going to have 3 equations with only 2 variables, but it's something that I'm sure you can do. Okay, writing linear inequalities. It's all about how you organize your information and how many things you have of each. Okie doke. Doke oak.